Are we recording? Yes. Okay, so unit number 6 is rational expressions and equations. And so lesson 1 and 2 are both simplifying rational expressions. So if we think back to previous courses, like even all the way back to like junior high and stuff, we know that a rational number is something like this. It's something that can be expressed as a fraction. So it even says right here, the quotient of 2 integers. So then they say the rational expression is similar in that it's the quotient of 2 polynomials. So it's like a fraction with polynomials instead of just integers. So it looks something like this, or like this, or like this. So both the numerator and the denominator can be polynomials. And so when we're working with these, we have to remember a lot of the factoring stuff we did, which is good because it's good review. So we have to remember things like GCFs and difference of squares and factoring by inspection and decomposition, which is just type 1 factoring and type 2 factoring and grouping. So pretty much everything we learned in factoring, we're going to be using in this unit as well. Yeah, a lot of it we used in the last unit as well though, right? When we were solving for x and stuff like that. So if we turn the page, we can look at this little chart and we are going to do where x is equal to 1. So let's just sub this in to our rational expression. So we'll go 2, 1 plus 2 over 1 squared plus 3 times 1 plus 2. And that gives us 2 plus 2 over 1 plus 3 plus 2. This gives us 4 over 6. And we can simplify that to 2 over 3. And so if we do that in this rational expression as well, we also get 1 plus 2 under 2 is equal to 2 over 3. So can someone put up their hand and tell me what they notice? Yeah, Kelsey? Yeah. So we say that they are equivalent forms. So we can actually prove that over here. So we'll go 2x plus 2, x squared, plus 3x plus 2. And so basically, to prove this, all we have to do is factor this guy right here. So for the top, we can see that we have a GCF of 2. So we'll go x plus 2. And then we can see that we have 2 factors, x plus 2 and x plus 1. And I made a quick mistake up here, so it should be x plus 1 at the top, because we take the 2 out of both terms. So then when we're looking at this now, we can say, oh, look, we have 2 factors that can cancel out, and that gives us x plus 2 over 2. Okay, 2 over x plus 2. Did I say it wrong? No, thank you. 2 over x plus 2. And so when we have it written in this form, we say that it's the lowest term or simplest form. So if you have a question that asks you to express it in the lowest terms or the simplest form, that's what they want you to do, is factor it and start canceling those terms out. Okay. So one thing to remember is that for something like this, like x plus 2 over 2, this cannot be simplified any farther. This does not equal 1 over x plus 1. Because if you divide something out, like here you divide by 2, you have to divide everything in the bottom by 2. So you can't get 1 over x plus 1 is equal to 2 over x plus 2. Okay? So that's just kind of like an aside, because this is a mistake that I'm sure almost everyone will make at least once in their homework. Okay, so if we flip the page, this time we're going to fill in the chart for -1. So we'll go, okay, 2 times -1 plus 2 over -1 squared is 3 times -1 plus 2. Okay, so we get -2 plus 2 over 1 minus 3 plus 2. So we get 0 over 0. Exactly. So when we have a 0 on the bottom, we know that we can't divide anything by 0. If you have a calculator, it actually won't even let you put it into your calculator. It'll say like error or undefined or something like that. Exactly. So we can try -1 for this one as well. So we'll go 2, -1 plus 2. Okay, are there any questions? Okay. So you'll notice that, oh, it's undefined here, but here we don't divide it by 0. Because this is our original equation, it doesn't matter. So when we're looking for things that make the expression undefined, we have to look at the original one. Okay? So we'll cross that out maybe even. It'll say in the question. So let's try it for -2 this time. So we'll go 2 times -2 plus 2 over -2 squared plus 3 -2 plus 2. On YouTube. Okay, so we'll go -4 plus 2. This gives us 4 minus 6 plus 2. And so now we get -2 over 0. So it's still undefined even though we have a 2 on top. It doesn't matter as long as there's a 0 as the denominator, it's undefined. So if we try it for this one, we can go, okay, -2 plus 2 over 2 is equal to 2 over 0. So for this one, we can see that it's also undefined. So -2 is a nice one for us, but we have to remember that -1 makes it undefined as well, even though in the simplified form, we don't get an undefined answer. Okay, so we'll talk about that a little bit more. Okay, so defined where something is not defined, all you have to do is you get to factor the denominator. So we'll go x plus 2 and x plus 1. And we know the denominator cannot equal 0, right? We'll go like this. And if you remember all the way back to the factoring unit, when we talked about the zero product law, it said if either of these is equal to 0, the entire thing is equal to 0. So we can write it like x plus 2 cannot equal 0, and x plus 1 cannot equal 0. And then you just, basically it's like you're solving for x again. So we go x. Yeah, if it's the denominator, then the denominator cannot equal 0. So we're saying that the factors can't equal 0. And then it's just like solving for x. So we say x cannot equal -2. If x equals -2, our denominator is 0. Okay, and then x cannot equal -4. Or -1. I don't know where I got the 4 from. Okay? So we call these non-permissible values. Got it? Okay, perfect. And then so for this one, you can do it the same way. So you go x plus 2 cannot equal 0, x cannot equal -2. Well, x can be basically anything except our non-permissibles. Based on what we know, it can be anything except those. Okay? Because right now we're just working with it. We call it an expression, right? So you see there's no equal sign, right? So we can't solve it, really. But we know that x cannot equal -2 and it cannot equal 1. Does that make sense? Kind of. Kind of. Okay, so here's some pretty solid study note stuff. So, non-permissible values are the values which make the denominator equal to 0. Okay? They're also known as the restrictions on the variable. So if you get a question that asks about the restrictions, you're asking what can x not equal. Okay? So they're asking, like, it's just like when we, when we were working with square roots and we had to figure out where the restrictions were because you can't have a negative. It's the same sort of thing. If they ask what the restrictions are, they're saying, where does the equation not work? Yeah, I would be at the non-permissibles. Okay? And then definitely highlight this, and it says the restrictions must be determined before dividing out the common factors. So this is like what I said before about you have to find the non-permissibles before you start to simplify. So you can write that, as Josh would say, in English underneath. So, okay, so find non-permissibles before simplifying. Okay, so let's do some examples. So the question says, express in simplest form, stating the non-permissible values of the variable. So even though the question, the first thing it says is express in simplest form, this is the first thing we have to do, is state those non-permissibles. And then we simplify. So to find those non-permissibles, that's when you take the denominator and you go, okay, this cannot equal 0. And you can divide both by 2. 2x, because that's what our denominator is. Okay? And then you find, okay, x cannot equal 0. So that's our non-permissible right here. X cannot equal 0. And then to express in simplest form, we just go, okay, is there a GCF? Sam, is there a GCF in this one? Okay, so we can see that our GCF is, can someone put up their hand and let me know? Yeah, Lucas? 2x, you got it. So we can go, okay, 2x, 6x. So all I'm doing is simplifying or factoring the top into 2 different factors like that. Because if we had 2x multiplied by 6x, we'd get 12x squared, right? And then you can cancel these out. And then our final answer is 6x. So I'm just kind of going through these with every single step. I did. Because it's like this. 2x and 1 then. Because our GCF was 2x, right? Which is equal to our bottom. Okay. So then if we look at B, B is kind of nice because it's already been factored. So, okay. So what's your question, Andrew? Yeah. So we did that right here already. Yeah. Yeah. So for B, because it's already factored, it just means we say, okay, we have two factors that have a in it. That means we're going to have two non-permissible values. So it's actually a little bit easier because they've already done part of our work for us. So we just go a plus 7 cannot equal 0. So a cannot equal negative 7. And then we go a plus 1 cannot equal 0. So a cannot equal negative 1. So these are our two non-permissible values. And then, because this question is so nice, they already have the bottom and the top factored. So right away we can look at it and go, oh, these cancel out. And we get a minus 6 over a plus 7 as our final answer. Like the non-permissibles? Yeah, because the question asks for it. Oh, so like in this one you can look at it and be like, oh, I know that's negative 7. Yeah, you can. These are really simple questions, so, and they get harder. So yeah, for these ones, like I said, for your notes, I kind of like to go through it in every possible step. But yeah, no, for something, a question this simple, if you had it on a test, yeah, go ahead and write negative 7 and negative 1 are non-permissible. Okay? So let's look at C. So with this one, our bottom isn't factored yet. So what would our factors be of y squared minus y minus 20? Someone put up their hand and let me know. It's just type 1 factoring. Yeah, and then what's the other one, Aaron? Yeah, y plus 4. Perfect. So that's how it factors. And then, so for our non-permissibles, we go y minus 5 cannot equal 0. So y cannot equal 5. Yeah. Okay. So like Andrew was saying, this is just type 1 factoring, right? So it's what plus what is equal to negative 1. What times what is negative 20. So this should be like mega review. Exactly. Okay, so then we get y plus 4 cannot equal 0. So y cannot equal negative 4. And there's our two non-permissible values. And then we get to simplify this. So we go, okay, y minus 5, y plus 4, all under y plus 4. And these cancel out perfectly. And so because we're dividing it out, this leaves us with a 1 on top and a y minus 5 as the denominator. Okay. Okay, so for this one, for factoring our numerator, we go, okay, what plus what is equal to 11, and what multiplied by what is 28. Good work. So 7 and 4. Okay, so that factors out our top. We have x plus 7 and x plus 4. And can someone put up their hand and let me know how we would factor the bottom? Yeah, Kevin? Difference of perfect squares. So, yeah, perfect. X plus 7, x minus 7. And so now that we have it factored, before we start canceling things out, we know we have to do our non-permissible values. We'd have two. So we have one here and one here, right? that's fine. So I'll show that in a second, okay? So we have x plus 7, so we know x cannot equal minus 7, and x minus 7 cannot equal 0, so x cannot equal 7. So you can write it like this, or if you'd like, you can write it like plus or minus 7. So both are acceptable. Because the negative 4 would come from the numerator, right? And so we know that if a fraction is like 0 over 2, that's okay, but we cannot have 2 over 0 sort of thing. Okay. So we have our non-permissibles, so we can start factoring or dividing out factors. So we go, oh, x plus 7, which gives us x plus 4 over x minus 7. Okay, and so that's lesson number 1. So instead of omitting all, we're going to move on to lesson number 2. Pardon? We'll let you know at the end of the class. We'll give it all together. Okay, so lesson number 2 starts on page 377. So you'll notice that lesson number 2 is called Simplifying Rational Expressions, Part 2. So we're doing kind of the same thing. So basically in lesson 2, we're doing the same thing, but we're working with questions that are more complicated now. So let's start with example 1b. Okay, so because this question is a little bit more complicated, I'm just going to organize it so that I'm factoring the numerator and the denominator kind of apart from each other. So I'll go, okay, top 2x squared is 5x minus 3. So let's factor this one. So this is a type 2 factoring, right? So we'll go what plus what is equal to 5, and what times what is equal to negative 6. So if someone can put up their hand and let me know. Jackson. Yeah. So 6 to negative 1, 6 to negative 1. Perfect. So we go 2x squared plus 6x minus 1x minus 3 is equal to 2x, x plus 3 minus 1, x plus 3. So we know our two factors are 2x minus 1 and x plus 3. So this is just in the numerator. Okay, so next we'll do the denominator. We have 2x squared plus x minus 1. And again, this is type 2 factoring, so what plus what is equal to 1, and what times what is equal to negative 2. Someone can put up their hand and let me know. Teresa? Yeah. Or negative 2 and 1? Perfect. Okay, so we go 2x squared plus 2x minus 1x minus 1. 2x, x plus 1 minus 1, x plus 1. And so our factors in the denominator are 2x, 2x minus 1, and x plus 1. So we can rewrite this as 2x minus 1 and x plus 3 over 2x minus 1 and x plus 1. Okay, so our non-permissibles, because they say state the restrictions, so that means find the non-permissibles. So we can go, okay, 2x minus 1 cannot equal 0. 2x cannot equal 1. X cannot equal 1/2, like that. And we go x plus 1 cannot equal 0. Go x cannot equal -1. So these are the non-permissibles.